Hi everyone, I hope you guys can hear me. If you would like to chat in the screen here, this is one of my first training sessions here, so if you could just chat in the box, let us know that you're able to hear us in this training session today. Looks like we have 22 attendees at the moment. All right, so my name is Eric. I'm one of the support technicians here at BobCAD. I normally do the demonstrations of the software program for potential customers and for any customers that would like to upgrade to any new modules that they don't have at the moment on their license, or upgrade to the newest version or one of the different versions that we have. Instead of the standalone version that we have here of BobCAD, we also have plugins for SolidWorks and for Rhino CAD now as well. So I'm going to try to look at you guys' chats now. Got Alan here saying that he can see my screen, so that's good. Got Chuck saying he couldn't hear me and now saying it's better. Cool. I've got a few chats in here saying that you guys can hear me. Awesome. So we're going to be going through 2D CAD and CAM features here in the software program today for version 34 for our standalone. Going to be going through some basic stuff. Now, again, to preface this, I normally do the demonstrations of the software program, so a little bit different than the training seminars here. I normally go through pretty vaguely how our software program works, and not too specifically on how to go through each individual CAD and CAM function. But anyways, we're gonna go through this and go through some specific CAD features in here, and then just a basic kind of way of going through 2-axis milling, getting a milling job set up, selecting our machine, and programming some basic features there. So the CAD functions that we're going to be going over specifically today are going to be points, and some of our 2D features here, 2D boolean, and our text options. That's going to include fit text to a curve, which is a pretty popular one in there as well. So with this file that I have in here, we're going to be creating some different points here on some of the shapes that I have in this existing file. So we start by going up to the top, clicking on this tab for Create 2D to create some of our 2D shapes here. Going to Point, and then we can drop down our options if I know exactly which one I want to select, or we can select them from the window here as well. From the Point, Sketch, and Enter function, we can go out and we can sketch out here wherever we want to. And we have some different options down here for enabling and disabling snap points. So I can start here, for example. It will create a point exactly at XYZ 0, and then it will snap every 16th of an inch, or every number that I specify here. So every 16th of an inch, you can see it snapping over each time. So I started at 0, 0, and if I move 1 over, it will go to 16th of an inch in X, and 0 in Y, 0 in Z, since I'm on a top plane here. So I'll get rid of those points that I've created so far, and we'll stay in that sketching option. We can turn off the snap option, and you can see we're sketching freehand. It's not going to go exactly at the X, or it'll stay at the X axis, stay at the Y axis for a second here, and then if I move over, I'll be sketching freehand with these points. Then speaking of staying on the X-axis here, we have this use construction geometry and X and Y tracking. So if I hover over an entity, it will pick up some construction lines here. So I'll go a little bit past this line that I hovered over, and it'll move over in the X direction, left or right. It'll move up or down in the Y direction, and I can click exactly on that line, so I can extend out the point further from that line there. Along with the snap point options, as you can see, when I hover over an entity, it'll pick up some snap points for us, the midpoint, the two endpoints of a line. It'll pick up every 45 degrees here on the circle. And when I'm clicking on lines, I normally show this in a demo too, when I start at a point, it'll also pick up the tangency point for every arc. So it makes picking up tangency points at arcs very easy now. We don't we have a line tangent feature, but we can do it automatically in our sketching options without having to click all of those different CAD functions there. So along with the different snap points, we have points from entity. So I'll select some geometry first. I'll hold shift and click on an entity. It'll chain select that whole rectangle that I created, and I'll select the circle here as well. Now with our different checkboxes, it gives us options on what kind of points it creates here with our different entities I've selected in the geometry box here. For example, intersection. It'll create points on all the different intersecting points between two lines here, between a line and an arc. So it'll pick up all of those intersections and create points along the intersection there. Same if I had any extensions going further out and there was an endpoint there or an intersection to that extension, it'll pick that up. Then from any endpoint, the only one that adds here is this 0 degree location from the arc is considered an endpoint for us here. We've already got the endpoints of all the lines selected, and now the middle points, it'll pick up the middle points of each of the lines here, and it'll pick up the 180 degree location of the arc here as a midpoint before it goes all the way back around 360 from our 0 location here. So those are the big options there with that point from entities option. We also have arc center. Since again this is a full circle, it doesn't pick up any center point for the arc there, but if this say for example if this was broken at the midpoint here and we had two 180 degree arcs, then it would give us an arc center point here, an arc center point here. Next we have our point incremental. So if I don't know an exact location where I want to create a point here, say 5 inches in X, 5 inches in Y at that location, if I don't know exactly where the location is I want to create a point, I can go over here to point incremental and say I want to move over in X 1 inch and move over in Y 1 inch from a certain point I want to start at. Say for example at this top point right here. I just click there and it will create a point in 1 inch in X and 1 inch over in Y to create that point. And then I can incrementally do that. If I want to highlight over that point, it'll move over and create those 2 points for us. But yeah, anywhere along those lines, say 2 inches, 4 inches, and start at a point, it'll move 2 inches in X, up 2 inches in Y to create a point. Anywhere in space for us, if I wanted to go above the Z0 plane here, go a couple inches above the plane here, you can see it raised 2 inches from there to help us out. We can do this off of surface edges as well, so that can be very helpful. If I want to raise a point above a 3D model or from a from a surface, I could do that there as well. So back to the 2D CAD options here. Point incremental, the next one is point on entity, where we have a few options here. Percentage, so if I want to go, we'll say 10% from a certain location, create a point there on an entity. So if I'm starting at this point here, I think I have to hit tab. There we go. Now I can hover over an entity. It'll go 10% from the distance of the 0 point and 10% over, or 10% up, for example. Or if my cursor is past the midpoint here of the line, it'll be in relation to the top of the line and go 10% downward that way. Same kind of option for the arc here. I'm going 10% around the circle. Or if I go below this 0 point of the circle, it'll go 10% downward of the circle. So I'll undo all of those points there. Our next option is distance. So we could go a quarter, similar option as the percentage, just instead of a percentage option, now it's a distance. So we're going a quarter inch over from the 0 point here, quarter inch from the 0 point going upward here, and then quarter of an inch from the 0 point, quarter inch downward from the 0 point of the arc there. And then we can change that distance however we want to. We'll say 2 inches around the circle if we wanted to, that way. And then an angle option, we can go from a certain angle from a line or from an arc and be able to, or mostly from an arc, I believe. So this is the 0 point from the arc. We could say 90 degrees from that point going around. You can see up here at the top, or downward. Actually, no, sorry. It only goes from this 0 point all the way around this way, counterclockwise. So if we said 270, then we can do that location down at the bottom. And then our last option here for points is going to be point perpendicular. So I have to have a pre-existing point for this one here. And then I can select that point for my selected geometry. And then I can select certain lines or arcs, it looks like, to create a point that will be exactly perpendicular to from that entity where it's going to be on that line there. So again, I'd have to select the point, select the line, and it will go perpendicular to the point I've selected all the way across out to that line I've selected there. So that's it with all the different point options that we're going through today. Next will be 2D boolean with these shapes here. If there's any questions you guys have, go ahead and put them into the chat. I know Al is looking at the chats here today, and I'll be looking at them at the end here to answer any questions you guys have. And if there's any other CAD features you may want to look at in another seminar, or any other CAD features that you may not have seen in BobCAD and you've seen in other software programs, go ahead and let us know, just to see any other CAD features that you're interested in looking at for another time. So from here, we'll go to the 2D boolean options. We can add, subtract, or intersect from shapes. We'll start with add, and we'll select different shapes here. So we'll start with the two rectangles. And again, I'm going to chain select one of them here. Just hold shift and click on one of the lines. Highlight the second geometry group, chain select the other rectangle. And now you can see with these entities, everything highlighted in orange here on the outside, this is going to be what we're going to keep of the shape. And on the inside, these red lines, these thinner lines here, are going to be what we're going to remove with this 2D boolean. So the 2D boolean add is going to add everything from the two shapes on the outside and create its own shape with this cross shape here. With the subtract, you can see it's going to subtract everything on the inside and subtract everything from the second geometry group. So it's going to keep the first rectangle, but subtract everything that the second rectangle is intersecting with there. If I go the opposite way here, I'll select this one as my first geometry group and this horizontal rectangle as my second one. And now you can see that my first geometry group, this rectangle is going to be kept, except for this area intersecting with the second geometry group. Then our last one is intersect. Select the horizontal one first, the vertical one next, and it doesn't matter our geometry selection for this one because it's going to just keep everything inside of what's intersecting of both of those two shapes there. So we'll go with the circle next. We'll do the horizontal rectangle there, and then the circle. This will be intersect here. It's going to keep everything intersecting between the two shapes. Toggle over to add. Add will create everything on the outside of the circle, everything on the outside of the rectangle here. And then we can select a rectangle and then the circle here. And then subtract will be, since I selected the rectangle again first, it'll keep the rectangle and keep anything intersecting on the inside with the circle there. Let me turn this off for a second here. Sorry about that. So that's going over our 2D Boolean, and I'll give you a better example, better real use example here for text and a piece of stock that we want to keep for cutting out this for a sign, for example, and leave this as a ledge for us. And to do that, we just go to 2D Boolean, select the text here, and then select the rectangle. Oops, sorry. Select the text first, and then select the second box, second geometry group for the rectangle. And you can see down here at the bottom, the rest of the text is going to be automatically removed and keep everything else for us so that we could do, for example, a profile around this, pocket the inside of these shapes out of the stock so that we've got a name and a ledge at the bottom for a sign, for example, there. That's about it with the 2D Boolean options there, add, subtract, and intersect. And then we can go to text here. Now we have some text created already in this third file. We have a circle, a full circle still, a line, and then 3 lines connected together as a chain. So to start off with, we might want to modify our text if we've already created it. To do that, we go into our select mode, select it, and then right click anywhere here in space, and we have an entity modify option. Now, once we've selected entity modify, it brings up this modify text option, this data entry box, basically the same as if I were to go back into if I were to delete it and go back into the text function and recreate it. Instead, we can just modify it here. We can modify the actual letters, numbers here. We can modify the height of it here. We'll say 1/4 inch instead of 1 inch height. We can space out the letters a little bit more if we want to. Add an extra 50 thousandths in between each of the letters there. If we want to angle the letters over, we can do that. We can bold or italicize the text, left justify, middle or right justify. So if I have a few columns here, this is left justify. We can center everything up, or we can do right justify. Or if we have more, everything will be starting from the right, the way we read it there. Then from here, let's see, what else do we have? We can still move the text over to modify it, and we can also change the font of it here. And change the text of it here while we're in this modify option. Now, after modifying, the other option in the text feature here is going to be vectorize. So we can vectorize the text and make it into lines and arcs as geometry. For some reasons, for other software, CAD software programs, you might want to export this into. It might not want text as an entity, and you can easily vectorize it, make it into lines and arcs. It could also help for engraving or any other 2D CAM features in our software program where you may want to just do an engraving operation on BobCAD and skip the CAM there. The text is considered all one entity, so when you select it as text, it'll do all of the engraving all at once. If you vectorize it into lines and arcs, then you can individualize or specify which pieces of the text here you actually want to engrave or do any other 2D CAM milling operations on. So from here, I might want to make it a little smaller still. And from here we can fit text to a curve. Now we'll start with a line here. This is the easiest one. So with the text, we can drop this down. We have our normal text feature and then our fit text to a curve feature. So with this function, we select the text first, and then we select the curve. And to do this, we select the entity once, give it the direction we're going, and we're going to refer back to our point selection where I want to select this entity past the midpoint. So we have the direction of the chain going in from left to right. So I start with one selection here by just clicking on the entity this way past the midpoint of the line, and then I hold shift and click on the line again to give us that chain selection of the entities we want here to fit the text onto. Since it's only one entity, I only have to click on the line, hold shift, and click on the line again. And then here's our alignment to path and how it's going to be formatted. So it's going to be formatted kind of like a right justify where it ends at the end here, or I can start from the start point of the line, or start from or have it centered up as middle. And then with the alignment to path, we have distance from the path, so I can space it out a little bit past the line a little bit. We'll say 1/8 of an inch. And then move text from the start point. So I have it centered. If I wanted it off center or wanted it 1/8 of an inch past the start point here, I can set that up. Move it over an exact distance there from the start point or from the middle or from the end there, kind of moves over off of the line there. Then from here, I'll undo that, and we'll look at fitting text to a curve on some of these other entities. We'll go to this chain selection, since we already brought up chain selection here. Fit text to a curve. I'll select the text. I'll select the curve option here. And now again, I don't want to click on the line to the left of this midpoint of the line, because then it's going the wrong way, and it's going to mess everything up here. The line is too short for the text anyway with this. But I can also show you the reverse direction. So I can click on this line, above the midpoint. And then I don't have to click on each entity individually. I can skip over this line, hold Shift, and click on this line. Now you can see it starts from the bottom and works its way up. I can also reverse the direction if this isn't the way I want to go. So I just click on reverse direction, and it reversed the selection of the chain automatically there. Now it starts, ends there at the end point. I can start from start, middle, end. But that's how we can go about chain selecting and fitting text to a curve along a chain of entities there. And then along with the circle here, we can fit text to a curve, select the entity. Now select this circle one time, hold Shift, and click again. You can go on the bottom here, going around, start at the middle here, start at the end at the end point of the circle, that 0 point location. I should be able to reverse direction also, and then this is from the end of the 0 point location, middle, and start. Now this, as you can see, isn't technically centered up, with the B here has a much larger distance here than the M. If I don't know the exact distance between the two, I can break up the circle, break it into two 180-degree arcs, so that I can just focus on one entity there to fit the text to that specific curve. So I'll go to my utilities, and then our break functions here. So a few of these break functions can achieve this. I can just go to break divide, for example, and break it into two halves there. I'll undo that and go to, that was break divide. Break screen should give us the same result if I click on the circle and click on one of these 2 points here to break it in half. And then I believe break angle would also, it would break at the angle of 180 degrees there. So those three would achieve the same result for us. And also same with the break entity. It's an extra step here, but if you're just getting started with the break functions here, now you can go to break entity, click on the circle, and break the circle in between the line here. Sorry, I missed one undo there. So we'll go back to break entity, select the circle, and then break it. I have to get the line past it, sorry. That should work. Break entity. No, it's giving us a problem with that 0 point location. So ignore that break entity. To break the circle up into two halves, we could achieve it in any of these three at least. Break screen, break divide, and break at angle. We just click on the circle one time, it breaks at the 180-degree angle point there. So from here, we can go to text, fit text to a curve, select the text here, and then again, fitting the fit curve option, I want to highlight the half circle here and click on it past the midpoint in this direction. So we've got the direction going clockwise. Hold Shift and click again, and then select middle. And now we've got it centered up automatically from that arc for us. As long as we don't have anything in here move text from start, we don't want to move it over and have it off center again. We have it centered up as setting it to 0 and setting it as middle there. And then distance from path, we can have it right on the line, or we can have it anywhere above the or anywhere above the arc, or right on the line of the arc there. I think that is about it with the text options, fit text to curve. Again, any questions you guys have with any of these 2D CAD features, give us a comment in the questions box there, so that we can have those for our next training seminars here, and to answer any questions you guys have with tech support also. So from there, we'll go to some different 2D CAD options, and I'll just select one of my demo files here for some basic 2-axis mill features here. So with this one, we'll look at profile and pocket operations, and to give us a better look at things here, we'll have an actual pocket in here instead of it being profiled out. And so once I've got my 3D model exactly the way I want it to look here, I can go to the top and go to CAM and start a new job. And then we can select our job type here. We have milling, turning for a lathe, mill turn for a lathe with live tooling, with milling tools involved as well, and wire EDM. We're able to support all of these different machines, and under the milling job type, we're also able to support laser, plasma, and water jet machines. These are all considered 2-axis, and they're all included in our Mill Express package for milling. So under Mill Express, you would be able to program for a laser, plasma, water jet machine, and a basic mill machine or a router. After we've selected what type of milling job type we're doing here, we can go to the stock wizard. We can define our workpiece. So this is only if we have a 3D model. If we have a 3D model, we can define it as our workpiece, as our finished 3D part that we're trying to achieve. That way we can see it in simulation and see exactly how much material is remaining to get down to our finished 3D model we're trying to achieve. So I'll show you that in simulation also, where if there's anything, any extra material we haven't finished up with the operations we've programmed so far, it'll show us in a different color, showing there's more material to be removed, so that we can go back and it's a good verification tool to make sure we've cut everything to size before we run it on the machine there. So our next page here, after defining the workpiece, is our stock definition page. So we can define the different stock here. If we've got, for example, a 4-foot by 8-foot sheet, and we've got a remnant of that sheet, we can define it here from the wireframe. We can extrude out from a sketch, let the software know that's our remnant sheet we're starting with, and see it in simulation. We have cylindrical option. We can pick a solid model as our stock that we're starting with. We're just going to start with rectangular stock here, remove the corners out of here, start with a pocket, and then do a profile cut, remove the corners, and remove these outside areas here too. We can make the stock larger here in our X, Y, and Z parameters. And then we can offset it. So with the X and Y and Z dimensions here, it will create extra amounts of material for our stock evenly distributed on both sides. So that extra 1/8 of an inch here is going to be evenly distributed in positive Y and negative Y for us. If I only want to add a certain amount in one direction, that's where these offset options come into play. If I want to add in the X direction an extra 1/4 inch of material, I can just add that in, hit the tab key to update, and we've got that extra 1/4 of an inch in the X direction, extra 1/4 of an inch in the positive X, and now in the positive Y direction, instead of adding any in the negative X or negative Y direction here. So I'll just hit 0, even everything up. And then our next page is our machine setup. This is where we're defining our work offset at. So if we're using our router or our milling machine and jogging the milling tool over to, say, for example, this corner I would highlight this origin point under machine setup and click on this point. That's now going to be X0, Y0, Z0 within the G code for my work offset number 1 for G54. If I normally set the work, or if I am going to set the work offset here at the center of the stock, I would just click on that point at the center, and that would now be X0, Y0, Z0 at the center of my stock for G54. If I'm using the tool and jogging down to the table, to the top of the table, I would click on this point as X0, Y0, Z0, if that's where I'm setting my G54. Now I'm going to set it up here at the top of the stock, a little bit safer than down at the bottom of to the table there, and I'll click OK. And so we've got our machine setup. This way, with our machine setup, as a side note, it's easier to set it up that way for our work offset instead of having to move over our work piece accordingly, our 3D model over, easier than if we import a 3D model or a CAD drawing even. If we import a file from another CAD software program and it's off kilter, we can easily just change the machine setup and change our X, Y, and Z directions, so we don't have to spend more time rotating the part around, translating the part over to the XYZ 0 location here of the CAD coordinates. We can separate the CAD origin here with the work offset that we're setting for our machine setup. And so from the machine setup, we can right click here in the CAM tree under machine setup 1, and we have our different milling operations. You can take a look at drilling and tapping first. Drilling and tapping, I select my geometry. There's no holes here, but I can select arcs. I can select points, and I can select sleeves of holes as well, and set the diameter of the hole, set the depth, whether it's a through hole or not. Again, I'm not programming for drilling right now. I'm just showing all of the options that we have in here. Our next page is where we can set the top and the bottom locations here. So we can start at the top and then tell the software the bottom of the hole that we would be drilling here. And it picks up automatically that it would be 1 inch down for the drill operation. Then our different available operations that we have for drilling. We have center drill, chamfer drill, chamfer mill around larger holes than this here, reaming and boring operations. Then if we're selecting many holes at a time to drill, we have an optimized sorting order. We can pick the order manually if there's a certain order we need to avoid any clamps or anything like that on the stock, or we can sort it in an X or a Y direction, or if we need to a custom direction in like a 45-degree angle like we're doing here. And then after that, setting up whether we want to setting up our work offset number, 1 being G54 again, and leave that alone for now, and then set up our parameters of the center drill that we've selected, and then the depth. And now for all of our drilling operations, we can do 1 single depth down, peck down into the material. So it will peck down and then go above the top of the hole location. Let the material remove as much as possible there, and then drill back down to the next step, or fast peck, where it won't go back above the top plane here. It'll just keep going, retracting a little bit each time, making it a little bit faster pecking feature there. So that's with drilling. And then with tapping, again selecting our geometry, and the only difference here is our machining strategy, where we have the same features here: center drill, chamfer drill, chamfer mill, reaming and boring operations. The only things additional here will be tap and rolling tap. So for example, if I wanted to do a center drill and a drill first, and then maybe a chamfer drill next after, I can do that, and then a tapping operation. If I wanted to do just a drill and tap operation, I would highlight each of these in the current operations list and delete them all out. Go to drill in our available operations list and add that in, and then add in a tap operation. You can see these are still set up by default, but if I go to the next page, everything will update where I don't have that center drill anymore, don't have the chamfer drill. I'm just doing a drilling and a tapping operation now. Setting the sorting order, setting the work offset number, setting up the drill parameters, the feeds and speeds here, tool number, the total depth, tap, and then the total depth for that. Now with the drilling and the tapping tools, we have an effective depth and an overall depth. Now the software, say for example, I'm telling the software I actually want the depth to be what it was before here. Anyways, so with the effective depth, say for example, if the hole is 550, so 0.55 inches down into the material, the software will understand that based on the angle of the drilling tool here, I have to get down to 0.6104 as the overall depth of the tool from that point, so that the angle, based on the angle, this point of the drilling tool will get down to that 550 depth there. I can change it if I want to. If I want to change the overall depth, if it is a flat tool, if there is no angle, I can change it to 0.55 manually. But I can just use cutting conditions and have everything set up by default there. So that's with drilling and tapping. And with tapping, we do have a thread library here. I go here to the tapping tools, go to our tool library. These are all preloaded in the software program for tapping tools, 1/4 inch, 20, all of those different options there. Now, after drilling and tapping, we can go to right-click on machine setup and go to mill 2 axis. Where again, we're just going to focus on some basic ones, pocket and profile for this part. So mill 2 axis, select geometry, select a circle. It's already set up by default to be a 1/2 inch down depth for the pocket, but I always want to double check. I'm going to highlight pick top and pick the top of the feature here, pick bottom, pick the bottom of the bottom edge of the pocket there to get our specific depth, make sure everything is aligned there, everything's correct. Now our next page, setting up a rapid plane, our feed plane. These are going to be for all of our milling operations where the tool will wrap it across at 200 thousandths across the part. It'll feed down into the material from 100 thousandths and then feed down into the material there. Total depth. And we are doing a pocket first. And we can go with a profile finish as well with this. Our available operations list includes a profile roughing operation where we can do multiple passes, a profile finish pass, pocket, facing, engraving, chamfer mill, corner rounding, all the basic operations there. Again, we support laser, plasma, and water jet machines that would be included with the profile finish here. We also support drag knife for a vinyl cutting machine now. That's new within the last couple versions of BobCAD where we can support vinyl cutting machines now as well for drag knife tools like this. So we have our current operations as a pocket and a profile finish. Our next page, tabs, we'll leave this alone. We'll go over that in the profile operation next for the outside of the part. Work offset option there for our G54 or different work offset numbers there. And then we can set up our roughing tool, set up the diameter, the corner radius. I can uncheck this box and use some manual feeds and speeds. Or if I check this box, use system feeds and speeds, these numbers are coming from our material library here. So what I did was I expanded the arrow from stock in the CAM tree, and it brings up, it expands to show us our material library. If I right click and edit, right now our material selected is carbon steel. If I change it to aluminum or plastic, we have feeds and speeds for each material type here. I have my own category for wood. I added this myself. You're not going to see that in there by default. You would have to add that group, name it wood, and then add a material type that you're using for wood. If you're using any wood material types, we don't have anything in here by default just because of so many different variables for wood. We don't have a set feeds and speeds list for each material type there. But once you add in the feeds and speeds for the material types here, it'll be set up by default for you. And these are pretty conservative numbers, I would say, for feeds and speeds. But we always recommend that customers contact their tooling manufacturer to make sure that those feeds and speeds are dialed in correctly for your specific tools that you're using. And you can see this is pretty fast for aluminum, 230 inches per minute. If I'm not able to do that on my machine, I can always manually change these numbers here. I'll go with 100 inches per minute just to see the time lapse in simulation there. And so our next page, we have some different cut patterns. We can start from the center of a pocket and offset, step over each time, work our way out. Start from the outside, step over into it and work our way in, stepping over. And then we have parallel, where we can zig or zigzag back and forth in between the pocket and then work our way out. Then with the advanced pocket, we have a couple other options here too. So with the parallel, you can see we can go one way where we can zig, go one direction each time, or zigzag. And then we have our morph spiral and adaptive roughing. These are our high-speed machining options. You might see different terminology with them, like adaptive roughing. Another term for it is dynamic machining or dynamic roughing. We can start at the center, continually spiral its way out, keeping constant tool engagement the whole time. So it's going to be a little bit faster. Our high-speed machining options faster than the offset options, instead of wasting our time stepping over each time. It's going to continually spiral its way out, not having to step over at all, continually machining our way outward. Same with the morph spiral, start at the center, continually spiral its way out from the center. Then we can set whether we want a climb mill or conventional mill, and set up our step over. We're going to be moving 50% for each spiral there, each step over 50% of the tool, so a 1/4 inch each time. Then we can leave a side allowance and a bottom allowance, so we're leaving 15/1000ths of an inch on the sides of the stock for the finished pass to clean up. We can also leave a little bit of material at the bottom of the stock to let a finished pass clean everything up on the bottom as well. Then we can do a single step down, so we could have the tool go down 1/2 inch and do one pass all the way around, or we can do multiple steps of cut, probably what we would want to do. And I'll set it at 1/8 of an inch. So every 1/8 of an inch is going to go down, do its pocket routine, and then go back down incrementally another 1/8 of an inch, and keep going 4 times, 4 numbers of cut. number of cuts. Then we can plunge, ramp, or spiral into the material, entering into the stock. So we can do the circular interpolation to start at the top of the stock and use the edge of the end mill instead of the bottom of the end mill plunging straight down. You can use the side of the end mill to start plunging into the stock a little bit better than using the bottom of the end mill there. Our next page here is our machine setup. So this is if we're doing multiple pockets, just like multiple drilled holes, we can set our closest sorting order. Again, if there was anything intruding, anything in the way of any of the pockets in between, I can manually sort them differently so that I can avoid anything that might be in the way, or set it in an X or a Y direction. Then we have linking for each step over, a direct link stepping over each time, an S link. So I can, once I've done this first pass, for example, I can move over a little bit before my initial start point from the last one, or a full retract to a clearance plane every time. And then same kind of options for between groups of geometry, little pocket area here, and then moving over around this area directly at with an S-link or a retract to a clearance plane there. And then our last page is our advanced feed rates. This is a new option in BobCAD as well. I believe most of these started in version 33. We have this corner slowdown in version 34. So when we're going into arcs here along a profile, we can set the feed rate percentage here for all corners. And we also have an arc look ahead option now as well. So arc look ahead count 3 steps ahead of the arc. We can set the number of divisions of the arc, different options like that with our corner slowdown now. And we've had these other advanced feed rates in here where we can convert rapid moves to feed moves. So if we're not able to set a rapid rate at the controller and we want to slow down that a bit, we can convert the rapid moves to feed moves to set that rate. We can set the feed rate where we're linking between groups of geometry to speed up or slow down that process. And then we have an adaptive feed rate option. And what this will do is when I set a minimum feed rate, when for example, when the tool is going into a corner like this here, similar to the arc slowdown, the software will calculate automatically how slow the tool needs to move to keep a constant chip load. So for example, we're going 100 inches per minute. If it needs to get all the way down to 10 inches per minute to slow down into the corners for us to reduce chattering, to remove less material at a time per tooth, we can get all the way down to 10% or even smaller if we need to. Then we're setting up our finish tool, setting the feeds and speeds, setting the compensation on the left or the right side of the path, giving us our climb mill or conventional milling options. We could also output for G41 or G42. Then we can, we're leaving 0 allowance for the side allowance, bottom allowance. This is our finish pass. We're just going to be doing one single step down. And just be plunging down alongside the inside of the profile here. We also have a lead in and lead out options, circular options, so go tangent along the circle, leading into it at a parallel or right angle option there. We'll just go with vertical for this here. And different corner type options. So if we're going around the outside of a profile, go around the corners, we can break up the corners with the loop radius, different options like that. I normally show this with laser or especially plasma cutters, where you don't want to stall too long in the corners here. That's a big one for plasma cutting. Some people use it for milling as well there. Then our machine sequence and our advanced feed rates like before there. So I'll hit compute. I know a lot of optimization options there, a lot of things that maybe some things I've skipped over or overlooked. And if there's any questions you have on any of those other optimization options, you can chat in or let us know with tech support if you have any other questions with any of those other optimization options there in the mill 2 axis. That's with the pocket and the profile finish. So if I unblank that, we can see everything here. The entry options or the entry moves here, the circular interpolation here is in green, so it's going to spiral around a little bit and then do the first depth of cut, spiral around a little bit more, and then it's going to, looks like it'll link across or link out with the green and yellow options there too. So after that, we can also backplot it, is where I expand the feature 2 axis, and for the pocket or for the profile finish, I can highlight it and then right click and go to backplot. This is where I can see individual milling operations individually versus seeing all of them all together in simulation, and I can follow along and see each move. I saw that entry, circular interpolation, entry move, and now it's going around. I'm stepping through. You can probably hear the click of my mouse every time moving around there at the first depth here of 1/8 of an inch. I could also let it play through if I don't want to keep clicking it, and then change the speed of it here too. It's a little fast for me though. So I can pause, step through a little bit more again. I can shade it. I can make the tool transparent or add a wireframe. I like this because then you can see it from a top view. You can see the actual tool, make sure there's not going to be any gouging or see the exact location of the end of the tool while you're following along there. You can see the current tool location, the feed rate it's moving at that specific location, the start point, and the direction that the tool's moving there. So I'll close out of the back plot. Everything looks good so far. We've got the pocket and profile on the inside of the part here, and now we want to do the profile on the outside of the part, finish everything up here. So we'll right click on machine setup 1, go to mill 2 axis, select geometry. Now, similar to the chain selection with wireframe for a drawing, there is a chain selection option for surface edges for programming here in the CAM portion. Instead of holding Shift and clicking on a line or an arc for chain selecting around a drawing, chain selecting around the outside of chain selecting this would be right clicking on a surface edge, and you've got 2 options here. You've got constant Z and you've got loop selection. The easiest one is constant Z. It's where you're chain selecting from one surface edge and chain selecting all the surface edges along that in the same Z at the same Z depth. So I've already just selected every edge for the profile cut around this part instead of having to select every little tiny arc here, every line. I've selected everything automatically. I can delete everything again, right click, so we have that constant Z, and we have loop selection. So loop selection is, it highlights some different edges on here on the part for me, where if I want to select one of these going in this direction horizontally like I did, now I've selected it just like I did for constant Z. Or if we're getting a little more a little further ahead of ourselves than we would with 2-axis milling, this would be more for 3-axis, 4 or 5-axis milling. You can define a boundary with one of these edges, this vertical line, or this bottom arc here, and now we've chain selected these surface edges of the top, the side here, bottom, and side. So if I've created a boundary for 3-axis milling or multi-axis milling, I've just set that up automatically for me. Another chain selection option. So again, just getting a little little bit past 2-axis milling at that point. So we'll go back. If we're going to be focusing on mill 2-axis, we're just going to right click and go to constant Z, because everything's going to be in the same at the same Z location there, the same Z depth. These arcs and lines aren't moving up and down from a front view here. It's all going to be flat. So from here, just like I did with the pocket operation, I want to pick the top and I want to pick the bottom for our total depth. As you saw, I'll go back into it, select my geometry, select my constant Z, edges here. Now, as you saw, it's set up by default as a 1/2 inch. So that's why I want to double check every time, where I set the top of feature, set the bottom of the feature for the total depth so that it updates to be 1 inch total depth for that profile operation, and not set up by default for a 1/2 inch like my pocket operation there. So our next page, we've already got a profile rough and a profile finish in here. If I wanted to add other available operations, just like with drilling and tapping that we saw before, I want to do another profile finish, for example, I can add that into my current operations list, and I can sort them however I want to as well in here. Now I'll just delete that profile finish. Again, I just want the profile rough and profile finish here. Next page, now we can get to tabs. So tabs along the outside of a profile, or you could do it for an inside. But say, for example, we'll go back to that example of a 4-foot by 8-foot sheet, and we're cutting out many parts, doing some kind of nesting work or things like that, cutting many parts out, most optimized way. And if we don't have what's called a vacuum table, a vacuum to hold the parts in after we've done the full profile of the parts out of a piece of plywood or a piece of OSB, a 4-foot by 8-foot sheet, or any dimensions there. If we can't hold it in with a vacuum, the cutter can go around while it's cutting, and then, for example, at this location, it'll retract. It'll go around this corner and then plunge back down, creating tabs along the corners, and I can add more if I want to here. So I've got one here, I want another one at this corner, another one at this corner, and another one at this corner, for example. So we would leave little small tabs here in the corners that could that would leave the part in the sheet for later on, where you could use one profile finish pass to cut it out, or you could file out the little corners here later, or you could also deselect these and then go along the sides of the part, for example, if you want to leave the tabs along the sides there. Different options. You can put tabs wherever you want on your part. If you're cutting it out of a sheet and you want it to be left in there because you don't have a vacuum table, you don't have anything clamping it down, you'll want to leave some little tabs in there for later on to fully cut it out later on. Now our next page, setting up our work offset number for G54, setting up the roughing tool and our feeds and speeds. I'm going to uncheck this box. Seems a little fast for me, so I'm going to go with 100 inches per minute here. And now with a profile rough, we can do a standard profile around the part, contour ramping, where it will do a helical ramp down into the material the whole time, or a side roughing option. So we can see here with our part, you saw the stock, the corners, there's a lot of stock remaining in there. I don't want the tool to go through the stock on both sides of the tool. I want less tool engagement that way. So I'm going to start on the outside corners and do some little tiny passes around or some small amounts of material for each pass around the corners to start off with before I do a full profile around the stock there. And so with side roughing, that's where we can do this. We have stock remaining. I don't know exactly the stock remaining left in the corners here, so I'm going to go with my step over option. and I want to step over 1/8 of an inch every time, and we'll do an additional, we'll do 5 passes from our very last pass of the profile cut. And from here, again, setting up our compensation, left or right side of the path, giving us our climb or conventional milling options, and we also have our G41 or G42 options here to output for the controller. And then we're leaving 15 thousandths side allowance again here. We'll do 1/4 of an inch. So we'll do 4 number of cuts again on the outside, just as we did for the inside for the pocket. We'll just plunge down. We'll plunge down because we're not necessarily plunging down into the center of the stock. We can work our way from the outside, and we'll use a lead in and a lead out for that. So again, we've got our parallel, right angle, and circular options. I'll start at a right angle and maybe go like start a 1/2 inch and work my way in there. 1/2 inch outside of the stock. Then we've got our different corner types like before with the previous profile operation, or going around the sharp corners, breaking up the corners with the loop radius, different options like that. Machine sequence, so if I'm doing cutting out multiple parts at a time out of a sheet, for example, closest sorting order, no sorting, so I can manually sort the parts here, set it in an X or a Y direction. And then our advanced feed rates like before, converting rapid moves to feed moves. Here with a profile, we can set a feed rate for our lead in and our lead out. So if we want to speed up or slow down the process getting into the operation, we can change our feed rate for those moves. Then we'll set up our feed and speeds and our tool for the finish pass, our system compensation, our allowance options. Again, it's just going to be 0 because this is our finish pass. We don't want to leave material there. And then setting up our lead in and lead out. Maybe I'll do another 1/2 inch right angle option there, for example. And then corner types, machine sequence, and advanced feed rates like before. We'll hit compute. Now we'll look from the stock. We'll unblank everything. So we can see, it looks like we're not getting right into the corner exactly. Maybe I'll go right back to the profile rough and add 2 more passes, for example. Looks better. And I want to see where we're starting our moves here. Looks like from the yellow linking moves here, it looks like this is where we're starting and ending the profile operations. And I can change that by highlighting default chain start point here. And yep, that's exactly where the arrow is. I can right click here and go to modify. Say I want it on the other side of this tab. I would just click that point, click OK, and then compute the toolpath again. You'll see these yellow linking moves move over to here, and this is where it's going to start now. And if I wanted to reverse the direction, so this is one other thing getting started with 2-axis milling that I'd like to go over, is that you may have seen I changed the system compensation both times from left to right. I'm going to go back to what it is by default here and compute. And you're going to see the toolpath change completely. It's not going to be on the outside anymore. It's now going to be on the inside. And the reason for that is because this default chain start point, it's set up going counterclockwise. So when we go to this compensation, if we can imagine this here, this blue line is the geometry selection of the profile, and so it's offset to the left of that counterclockwise direction. So that may have been why I know a lot of customers have issues with this to begin with 2-axis milling. This is one of our biggest issues, is where if it's compensating to the left and going counterclockwise, it's going to be doing an inside profile cut. So that's why I changed it to right. It'll be going counterclockwise and offsetting to the right every time. Or if I want it to do the system compensation to the left, I have to have it move clockwise to go on the outside. So to do that, I right-click on default change start point, and instead of modify, I select reverse direction. You'll see this arrow. I zoom in here. You'll see this arrow reverses direction. And then I just compute the toolpath, and the toolpath will be on the outside of the part again. So that is the difference between our system compensation, our compensation options on the left or the right, in relation to our default change start point and the direction of the profile cut there on the inside or the outside. So anyways, we've got what looks like some pretty clear toolpath with the pocket and finish profile on the inside, and then profile rough and profile finish on the outside here. And we will look at that in our simulation now. Bob, can the default depth be changed? Yes, I believe I went over that. It is set up by default for a depth of 1/2 inch, but if you saw the top of feature highlighting those boxes, top of feature, and then selecting the top edge of the stock, or top edge of the feature, and then bottom edge of the feature, it automatically sets up the depth that way. And you can also manually change it if you know exactly what it is. And actually, that brings up a good point with the where if you don't have a 3D model, if you just have a drawing and you're looking to do a profile or looking to do a pocket inside of a 2D drawing that you have, you're not able to pick top of feature and bottom of feature because technically there is no bottom of feature with the drawing. It's not 3D, so you'll have to type in manually that amount. But one of the benefits of using a 3D model is that you're able to just select the edges of a 3D model, and the software will understand exactly what depth you're trying to get down to. Again, if you don't have the 3D model, you'll have to know that exact depth. So the first operation we saw while I was talking was that pocket on the inside. That's the pocket operation, and then the profile rough operation on the outside. It's doing that 1/4 inch depth of cut each time, doing 4 number of cuts down at the full depth of 1 inch for this stock. Derek, what is the most efficient to draw one line? Now that's going back to CAD. Sorry, since I finally have some free time with simulation here. Now under the Create 2D tab and then going to line, you do have, you're able to click one point and click on another. And I think the most efficient, at least getting started with drawing, would be you can set your start point in coordinates, in X and Y coordinates. So if you want to start at X0, Y0, you just type those numbers in. And then under absolute, you can type in the absolute coordinates where you want that line to end at. anyways, I'll get out of the chat here. So if you saw the pocket and then the profile on the outside and then the profile finish pass on the inside, I'll go back to that operation here. Slow it down so we can see it. So we're at the point where we saw the pocket, we saw the outside profile roughing. Oops, we're going back to it. Skip that. Okay, so that was the profile roughing. And now the next one is the profile finish pass. We're removing that extra 15 thousandths of an inch, that side allowance we had previously, and then the other 15 thousandths of an inch on the outside here for the finish pass from the profile roughing on the outside. And now this is already set up by default. You might not see this by default in your simulation, but under the window that says analysis here, there's a drop down. I think normally it goes to none. And you have many different options in here. You can see, you saw the color change here. If I change it back to tool number or operation number, it'll have different colors on here depending on what operation or what tool I'm using while I'm removing the stock from that area for each tool number 1 and tool number 2. Operation number, so I've got 1, 2, 3, and 4 different colors, and I can even change the colors here. I want to see different colors, and then refresh. And so that was tool number and operation number. And then the other one we're going to look at here is deviation. This is what I was talking about before, where if we've got a 3D model, we can let the software know the workpiece, our finished 3D model, our desired finished part that we're trying to achieve, and is going to load different colors on the stock depending on how much material is remaining. So now everything in green is everything that is cut to size. So I can see here in the pocket that 1/2-inch cutter was able to get around inside of the pocket and cut everything down to its total depth along the side here. So another side note, if I didn't select the depth correctly, this deviation report would show if I went too far. It'll show here in yellow, orange, or red if I cut too far into it. It'll show a blue color if there's still material remaining. So if I didn't get that depth all the way down I was supposed to, it would still have a blue color showing there's more material remaining. Now, we zoom in. We're seeing this blue color. So 1, 2, 3 is somewhere around 45 thousandths of an inch is remaining here in the corners on the insides of each of these tabs. And the reason for that is because the cutter, the 1/2-inch milling tool, oops, is too large to fit into this radius. So the 1/2-inch milling tool is not going to be able to fit into, I believe it's a 1/4-inch radius for the tab. So what we can do, it's again, the simulation deviation report is a great verification tool to make sure everything is cut to size that we can see in simulation. So we're verifying and seeing that we haven't cut to size yet. We're going to close out of simulation and we're going to go back to the profile finish. So what I did is I just right-clicked on profile finish here in the CAM tree and edit. I'm here automatically at the tool page for my finish tool. I don't want a 1/2-inch cutter. I can easily just change it to a 1/4-inch cutter right here if all the other parameters are correct, or I can go to my tool library and select one of my tools that will cut this out. We could do a 1/4-inch cutter. I'm gonna just arbitrarily, I'll select an 1/8-inch cutter because that should remove everything on that finish pass. So now we've got an 1/8 inch cutter for the profile finish, and hit compute. Go back to our simulation. Another side note here, at the top of simulation, it's showing us our estimated cycle time. It says it will take about 9 minutes and 48 seconds based on that 100 inch per minute feed rate I've set for each tool there. So it's related to that feed rate. So if I go into one of those tool pages and change the feed rate, it'll change the estimated cycle time here at the top. So it'll give you a good estimation so that you can quote out jobs and things like that. So going through the pocket and the profile rough operation here, again, and then getting to the profile finish on the inside of the pocket, and then a profile finish on the outside of the pocket. Now we're looking at red and green here as a collision, because the tool, the cutting part of the tool is only right here. So we've got an extra 1/2 inch of the non-cutting part of the tool gouging into it. We'll just kind of ignore that for now. We'll just assume right now that tool has a cutting area a little bit taller than what that was. We'll refresh this deviation report. Should get rid of that red for us. And we'll want to look in the corners and see the specific colors in the corners. Make sure there's no blue in the corners. Everything is cut to size from what I was trying to make with our finished 3D part. So everything is cut to size. Now that everything's cut to size, we can review everything, make sure the feed rates are what we want, plunge, feed rate, and all of those operations. Once everything is done, we select a certain post-processor. So the next step is our post-processor, where it's this icon of a controller. We right-click and edit. We can select our post-processor. So the post-processor is a file that will format the G-code specifically to your controller type. So if you're using a Bailey machine, like one of our partners as a router for a Bailey machine, or BC stands for BobCAD, one of our generic milling machines here. If you're using a controller for Fadal, Fagor, Fanuc controller, you can select one of the specific controllers here. If you don't find your specific controller here in the library of post processors, you can go to our website to our support page, where you can download other post processors into the software program automatically. If you go to bobcadsupport.com, there's an option there at the top where you can download a post processor. When you download it, it will download as an exe file. And when you run the exe file, all you have to do is check the box of what version you're using of BobCAD. It will automatically install the post processor in, and it will also select the specific controller by default. So if I've selected for a Haas, if I installed it from the website, it will set that up by default for us automatically. If you want to set up a Haas controller, if you want to set up the post processor as Haas or anything else by default for any new milling job, all you'll have to do is right click on CAM defaults and go to current settings. Here's where you can select the machine that it will select by default. I don't want Shop Sabre router anymore. I'll select Haas for this one. So I'll save as a default for that machine type. And then I'll go to posting. And the post processor already is Haas 3-axis because it linked it from that machine. But if it was anything different from Haas OEM, say if it was a 4-axis mill, I'd select that Haas 4-axis mill. Now every time I go to a new file, I'll just do that real quickly, and go to CAM, go to a new job. We've got that Haas mill machine in there automatically for us by default. Instead of having to drop down from the BC3X mill every time for your specific machine, you can set it up by default here in the CAM defaults page. Other cool settings here in the CAM defaults that you can default to under posting, you can set the file extension type. So if your machine or if your controller doesn't take .nc for your file extension, some other common ones are .tap, .cnc, or .nc. You can default that file extension name. Can default the program number, sequence numbers, other options like that here in the CAM defaults too. So that is for defaulting for a new milling job. If you wanted for your existing milling job here, it'll be under milling job CAM default current settings. So CAM defaults current settings for defaulting things for any new milling job. For your existing milling job here, it'll be milling job, right click current settings. Posting, file extension, program number. If you want to post out your specific program number for this file, you would go under milling job, current settings, posting, program number. Now I think we're finally able to post the G-code. We've simulated. We've seen that the areas here into these tab areas here are cut to size. Everything here is cut to size on the part. So after simulation, stopping simulation, we have post. It will post the G-code here on the right-hand side. And again, this is set up for a Haas controller, this formatting. Now, if I go back to the post processor selection, I just want to show the differences between the G-code from a Haas to, let's go with Bailey, since I know that'll be a bit of a different G-code formatting here. So I can highlight it and click open, or I can double click and select that post processor, hit OK. And now if you look at it right here, get kind of a visual representation of how it looks with the formatting. Oh, okay. Here we go. So yeah, so we've got our %, program number, comments here in parentheses, and this is the start of the program, some safety lines, comments for the first cut, first tool, tool number 1, and then starting the machining from there for a Haas. Here's the formatting for Bailey. A little bit different, a little more basic, where you don't have any comments in here. You don't have anything telling you here's the first cut. It's just going right to the safety line and tool number 1. And you can see even the formatting, the feed rate is 2,540 because it's in metric versus inch there. So a lot of differences between the post processors. That's a really big reason why you want to get the correct post processor for your controller. What I would recommend, especially if you have any Fanuc controllers there, you could go to BC3X mill. That's our BobCAD 3-axis mill machine, and that is a Fanuc-based post processor. So that's pretty generic for controllers that you can test, do a dry run of if you have a Fanuc controller or any other generic controllers like that, anything basic like this here. If there's any other post processors that you need that you don't see in our library, post-processors in our software program by default. Again, you can go to bobcadsupport.com and download the post-processor that you need. If you don't see it in that library, contact us at support@bobcad.com. I'm one of the technicians there. We can help you out with getting a post-processor ready for you to format the G-code specific to your milling machine here. So that is about it with the 2D CAD and the 2-axis mill that we're going over today. Please leave any questions in the chats I can get to later on. And again, if you have any questions with what we went over today or anything that we didn't go over that you still have questions on, you can also ask us at support@bobcad.com. Thanks everybody for viewing our seminar today. This was my first one, technically. Again, I normally do the demonstrations of the software program, but this is my first training seminar. So happy it went pretty smoothly, and happy we had 30 attendees overall attending here today. So thanks everybody for attending and staying along with me. And I'll see you guys in another video. You guys have a great day.